Hey, this is Joe, and today we're going to talk about finding the x-intercepts of a function. Every x-intercept has a y value of 0, and so the format of an x-intercept will be some number comma 0, where the number that's in the x position is the solution to f of x equals 0. So let's look at a function graphically and talk about an x-intercept. Let's look at f of x equals 1/5 times the quantity x to the 4th plus x to the 3rd minus 7x squared minus x plus 6. The graph of the function looks like this, and we're looking for the points on this graph that cross the x-axis. In other words, the points that intersect the line y equals 0, the horizontal line that represents the x-axis. It looks like we have 4 of such points. We have the point -3, 0, the point -1, 0, the point 1, 0, and the point 2, 0. And for this particular type of problem, a polynomial, we would factor the polynomial completely if we can, and we would simply set that entire function equal to 0 and find the x values that satisfy that equation. In other words, what values of x make this factored form equal to 0. And to find the solutions, we would use the zero product property, and we'd see that -3, -1, +1, and +2 are all solutions to this equation. Now, it is true that setting your function equal to 0 and finding the x values that satisfy that equation will get you x-intercepts, but from one function to another, depending on what function group it's in, the method for finding those x values may be different. So, let's talk about 3 different groups of functions, and first we'll talk about the exponential function. And these functions take on the form f of x equals a to the x power, where a is just some positive real number. And because of the nature of these functions, they're going to either have the form where they're always increasing or always decreasing, such as this graph we see here. And that tells us that there's at most only going to be one x-intercept for an exponential function. Now let's talk about polynomial functions, and these take on the form shown here, where an through a0 are just going to be real numbers. And here's the graph that we showed earlier when we were working with a polynomial function. And the interesting thing about polynomial functions is that their maximum number of x-intercepts is equal to the degree of the polynomial, or the largest power of x. Now let's talk about trigonometric functions. For example, consider f of x equals sine of x. And below you'll see the graph of sine of x, where you notice that it has a bunch of different x-intercepts within the interval shown. And if we were to extend either of those intervals to infinity, we'd see that we get more and more x-intercepts as we extend our graph outward. What that means is that we can have an infinite number of x-intercepts when we're working with a trigonometric function. Now, these are just 3 groups of functions, and each grouping of them have a different rule for how many x-intercepts they can have. And so, unfortunately, I can't guarantee a method on how you can find your x-intercepts other than for each function, you're going to set it equal to 0 and find values of x that solve that equation, and then you'll get your x-intercepts. I'm Joe, and thanks for spending some time with me.